Hi, this is the first short video just showing how the RobotStudio fires up and how it looks like, the general layout, uh, the user interface and so forth. So it looks like most software with some uh, tabs here for different ways you should do, so to say. It's a file, home, modeling, simulation, controller. Controller is actually robot controller. Rapid is the language to program ABB robots, add-ins, specific things that might need to be inserted into the system, like a robotware. Robotware is the software for the controllers used. You might need that, like this here, and you just add. Now there is a new one here, 61002. So just click on add and accept, and that should be added to the list of controller software that you have access to. I think that is something that should be done. Okay, anyway, we'll go back to file, and what we see here are options. Options is one thing, is licensing, and you need to make sure that you have a network license. I want to specify network license server to manage server licenses, and click on that one, next, and it should look like this: veron.lnu.se server is online. If you haven't done it before, do it now, and then it will say that you need to restart the software. Let's click on OK. Finish. If you just look at view install licenses, they are all valid now until 2021, so that is fine. Close. Okay. There are more options, of course. One can look at that. For example, there are options related to files and folders where things are. And in my case, this is my path on my computer. It might be totally different on your. If you have only one drive, it's a C drive typically somewhere under your username. Okay. So, and then there are two ways to open and save files, models. One is just using OpenSave. OpenSave, if you always use on your own computer, you can rely on doing that. But when you create a model and you save it, it will be saved using an XML type of file structure with links. So if you, for some reason, delete some files within your computer that is included in the model, that will just be destroyed. It will not be working. The other way, which might in some cases be recommended, is to use a share, open and save. And that is called pack and go files. I think I will use both actually. But in this case now, just to open something, I use the share, unpack and work, because there are a set of demo files that they will just bring up, and so you can see how it looks like. I have a folder called RobotStudio where I have everything. I have some demo files, and those are actually included in the installation. So one such, I can take this one, an arc welding station. Looks like this one. You see here, and open, and then I select the target for that one. Usually we put all the models for a system in a folder called solutions. In this case, then solution demo arc welding station, which is the same name as the pack and go file, and that's fine. And also the target folder should be empty when we do this. Load files from pack and go. Yes, next. And settings for that, we just take it as it is. Next. and finish. And then it should unpack, creating version controllers. And it takes a while restoring backups. It depends about the complexity and so forth, but actually it sets up several services to bring it to live. One service relates to the station itself and user interface and all that, those kind of things. Another thing is actually related to the controller because they are working together. Okay, the library of the robot has been superseded by a new version. Do you want to use the new version? Yes, we want to use the new version of the robot. That's much better. Close. It's done. So it looks like this now. So to move around in the user as a user, if I hold down the control key and with the left mouse button, I can pan around like this one. That's fine. If I use control shift, I can rotate this one. And I can zoom with the middle wheel button, so to say. I just turn the wheel, the middle wheel, and I can zoom in. So basically, control left, pan, control shift, rotate, zoom in out using the wheel. That's pretty simple. And sometimes I just get lost. I don't know where I am, or if I want to rotate it, it rotates very strange. Then I just click on somewhere here, rotate, right click, that one, and view center. Now that is the new center for rotation. So that is pretty simple. And then if I got totally lost, I don't know exactly where I am. Really, really strange. I don't know anything. So just right click, view all. Like that. It will come back. Okay, that is pretty simple as it is. So this is actually how it looks like. Now if you want to run something, yeah, you can see, I mean, you can place whatever you like here. You can zoom in and yeah, actually the way people, now I got lost with the rotation. So I right click, view center on the welding gun like that one. So we have an example here with something which is actually done as a demonstration with paths for the robot. It also has some physics with some cables here for the arc welding dressing of the robot. But we have a look at it, how it looks like. So we have to click on simulation and play. And while we do that, we can have a look more detail how it looks like, how it operates. And this should be pretty accurate as it should be done in a real robot station because it runs the same controller software as it would be doing for the real physical robot, so to say. So the accuracy related to that one is pretty true in a way. So it's kind of a digital twin in that perspective. This is also a normal setup of an arc welding station where we have the same type of work object on this side. It just moves around, and then when it was ready here, a human operator comes in, takes away this one, load it with a new object, walks out, and it can continue. And the safety arrangement is done in a way that it allows the person to enter in here one way or the other to do that kind of task, walk out. Usually clearing that it has left the area as well, and the robot can operate with its welding operation like this one here with no problem. So that is basically how it is. Now programs. Well, we just stop it here, look at the program. Programs are written in the Rapid code, and it looks like in this one here. We open the Rapid container, and we have the main module here. So this is basically how it works. There's always a main module that, or a main procedure that gets the ball rolling, so to say. It always starts with that one, and that includes a number of procedure calls. Typically, then procedure calls are paths to go through, and if we open this one, that will contain the data needed actually to run the program. So these are a set of rob targets, which are actually the positions to move through. And then we have procedures for the first part, which are calls for different paths, path 1, 2, 3, 4. And then we have part 2, the same thing. And then we have part 1, path 1. With a set of actions for moving and the arc start related to the welding power source and so forth. So that is basically how programs look like. Okay, simulation we had. There are a set of things there as well to get simulation in the proper way as we like it. We'll go through that in the exercises later on. So I think with that we just stop and start in the next video session about the first exercise. Okay.